Hello everyone, welcome back to Vyasa IAS CSAT course. This is lecture number 39 of time and speed. So let us begin with the lecture. Okay, now we have already seen time and speed concept when we were in school, but let us try to analyze the equation. Okay, so we have a very simple equation that is speed into time. अरे थोड़े तो धीरे उतरो यार. So we have a very simple equation: speed into time into time is equals to distance. But our questions will not be so simple. Okay, so basically, if we try to analyze this equation, speed into time is equals to distance, you will find different types. So basically, when we analyze this equation, speed into time is equals to distance, you will find different types of relationships we can find about this. Okay. So what we will do basically here, we will keep one thing constant and then we will try to know what are the variations available. Okay. So let us do this. So the first case that we are taking here is that direct proportionality between time and distance. Okay, so let us keep speed is equals to constant. Okay, so when we have this equation speed into time is equals to distance. So whenever we keep speed is equals to speed constant, okay, then we get time is equal to time is directly proportional to distance. Okay, then we get time is directly proportional to distance. So what we do here basically is, when time is directly proportional to distance, then your t1 divided by t2 is equals to d1 divided by d2. Okay, your t1 divided by t2 is equals to d1 divided by d2. Fine. So that means what? If any question is given, for example, look at this question. It is given a car moves for 2 hours at a speed of 25 kilometer per hour, and another car moves for 3 hours at a speed of at same speed. So find the ratio of the distance covered by the two cars. Okay. So basically it is saying that we are having two cars and both are moving for time t1 and t2. Okay, and both are moving at same speed. So cars C1 and C2 are moving at same speed and they are moving for time T1 and T2, and we have to find the ratio of the distances covered by the two cars. So the ratio of the distances covered by two cars D1 and D2 is equals to 2 is to 3. Okay, so the ratio of the distance covered by two cars uh, uh, C1 and C2 will be 2 is to 3. Why? Because the ratio of time they are traveling is equal to the ratio of the distance they are traveling. Okay, and now if you know the distance traveled by any one of the car, for example, let's say that uh, obviously you know that uh, uh, this car is moving for 2 hours at 25 kilometer speed. So this one is traveling 50 kilometer, and for 3 hours then this one is traveling 75 kilometer. If you take the ratio, obviously 25 two times and 25 three times, you get the ratio 2 is to 3. Okay, so we don't have to calculate the by this method. Okay, we just have to see that whatever be the ratio of the time, that will be the ratio of the distance itself. Okay, so whatever be the ratio of time, that will be the distance itself. Okay, so that is it. Now let us look at the second equation. So we are saying that there is a direct proportionality between speed and distance when time is constant. Okay. So when time is constant, so then also we get the equation S1 divided by S2 is equals to D1 divided by D2. Now where we will find the application of this equation? Okay. So for example, a statement like this is given: a body travels S1 kilometer for the first 2 hours and then travel S2 kilometers for the next 2 hours. Okay. Now this body, now your time is constant. 2 hours only. Okay. Now S1 kilometer it is traveling for the first 2 hours. Okay. And S2 kilometer is it is traveling for the next 2 hours. So your ratio of distance will be given by S1 and S2 only. Okay. So if anyone asks you that for 2 hours one body is traveling by speed S1 and in the same 2 hours another body is traveling by speed S2, what is the ratio of their distance? So the ratio of their distance is S1 by S2 only. Okay. So D1 by D2 will be equal to S1 by S2. Okay. So don't get too much confused and worked up whenever these kind of question are asked. Uh, it is similar. The ratio of your distance will be the same as the ratio of your speed only. Okay. So this is it. Now, what is the another kind of question that can be asked here is that two cars start simultaneously from A and B respectively towards each other with the speeds of S1 and S2 kilometer and they meet at point C. Okay, so two cars start simultaneously at S1 and S2 speed. Okay, two cars start simultaneously from A and B at S1 and S2 speed towards each other with the speed S1 and S2 kilometer and they basically meet at a point C. So basically here what is happening, two cars they are moving towards each other. Okay, now see, they will meet at a point. Okay, now the ratio of their distance, obviously you will know that S1 by S2 is equals to D1 by D2. This will be the ratio of their distance. S1 divided by S2 will be equal to D1 divided by D2 and total distance traveled will be D. Okay, so D total distance traveled will be D1 plus D2. Okay, now if you know the total distance D here, obviously you can find out how much this one car is traveling, how much is another car is traveling, or at what point they are meeting. Okay, or at what time they are meeting. So you can find all those things. Why? Because we are able to establish that S1 divided by S2 is equals to D1 divided by D2. Okay. Fine. Because see, if they are meeting at some place, so actually they are meeting at the same time. Okay. So for example, if they are starting from here, okay, they are starting from here to cover this distance D. Okay. So even if it travel distance d1 and even this travel distance d2, okay, depending upon the ratio of their speed, the point at which they meet, actually the time they are traveling till that point is same. So here time is equals to constant. Okay, recognize this thing, that whenever two people are meeting, they are the time they are traveling is same. Okay, fine. Now let us look at the third condition. The third condition is inverse proportionality between speed and time. Okay, so if distance is kept constant, so we have this speed into time is equals to distance. Now we keep this distance at constant, so s1 divided by s2 you will get t2 divided by t1, or time 2 divided by time 1. Now see where this will be applicable. Okay, let us look at what are the conditions where this will be applicable. See, here we are saying a body is traveling s1 kilometer for the first half of the journey and then traveling s2 kilometer for the second half of the journey. So here distance is constant because first half of the journey and second half of the journey. Okay, now they are traveling for s1 and s2 kilometer. Okay, so obviously the time taken to travel will be in what ratio? The time trickle will be t2 divided by t1. Okay, the time will be t2 divided by t1. Okay, so if someone asks you what is the ratio of the time, what is the ratio of the time taken? Okay, so t1 by t2 will be s2 by s1. Okay, t1 by t2 will be s2 by s1. Remember this thing. Okay, whenever distance traveled is constant, distance traveled it's constant, and you want to know the ratio of time, so that will be T2, that is T1 by T2 will be equal to S2 by S1. Okay, that is inverse of your ratio of speed. Okay, or the ratio of speed will be given by what? S1 by S2 will be given by T1 by T2. Okay, and this also implies what? That S1 into T1 is equals to S2 into T2 because distance traveled is same. Okay, so that is S1 into T1 is equals to S2 into T2. So this also makes sense. Okay. And see, in this question also it will be applicable. So it is saying two cars start simultaneously from A and B respectively towards each other. Okay, and if they are trying to travel the same distance, then also your um, uh, equation will be applicable. Okay, what is the equation? S1 by S2, and that is equal to T2 by T1. Now we will see the application of all these concepts. Okay, how they are being applied in questions. So we'll see this and then we'll move on to the next concept. Okay. Okay, so let's now go deeper into solving some questions. So let's begin. Uh, Now look at this question, what this question is saying. A car moves for 2 hours at a speed of 25 kilometer and another car moves for 3 hours at the same speed. Find the ratio of the distances covered by two cars. So when you are doing these kind of question, determine what is constant in the equation speed into time is equals to distance. Okay, because our entire chapter will be based on speed into time is equals to distance. So here speed is constant. When speed is constant, we know that T1 divided by T2 is equals to D1 divided by D2. So it is asking about the ratio of the distances covered by two car. So T1 by T2 is equals to 2 is to 3, which is also equals to D1 by D2, and the ratio of D1 by D2 will be 2 is to 3. Okay. So whenever any question is given to you, please pay attention to the concept that what is constant here, then we will be able to find very easily whatever is required. Okay, so this was our first case. Now let's look at the second question. Look at this question. It is saying a car travels at 30 km per hour for the first 2 hours, okay, of a journey, and then travels 40 km per hour for the next 2 hours of the journey. Find the ratio of the distances traveled at the two speeds. Okay, so here we are given S1 and S2, and here time is constant. Okay, so we already know that when time is constant, okay, when time is constant, S1 by S2 is equals to D1 by D2. So it is asking about the ratio of the distances traveled. So D1 by D2 is equals to what? 30 by 40. So that means 3 is to 4. Okay. So obviously, 3 is to 4 is the ratio of the distances traveled. And obviously, you can tell by direct multiplication also that 60 by 80 is also 3 is to 4. Okay, 60 by 80 is also 3 is to 4. So that is it. But this is a very simpler way of doing things. Now, again, look at this question. It is asking two cars leave simultaneously from point A and B on a straight lines towards each other. Okay, so we have this point A. Let us consider this point as B. Okay, and two cars A and B are moving towards each other. Um, um, Two cars are moving towards each other, okay, on a straight line. The distance between A and B is 100 kilometer, it is saying. They meet at a point at a point 40 kilometer from A. Okay, so they are meeting at a point 40 kilometer from A. Find the ratio of their speeds. Now listen to this thing. We have this equation, speed into time is equals to distance. Here what is constant? Here time is constant because they are meeting at 40 kilometer from here. So that means at the time they are meeting, they are starting simultaneously and meeting here. That means they have traveled a similar amount of distance. Okay, sorry, they have traveled for the same amount of time. So here time is equals to constant. Now it is asking find the ratio of their speeds. Okay, so we already know when time is equals to constant, S1 by S2 is equals to D1 by D2. Okay, and D1 is how much? 40 है ना. If we talk about A, the car that is starting from A, let us consider this car as C1, and we are considering this B car as C2. Okay, so D1 is actually how much? 40 kilometer, and D2 is how much? 60 kilometer, because total distance is 100 kilometer, and it is asking about the ratio of their speed. Okay, so that is obviously 2 by 3 or 2 is to 3. Okay, so the ratio of their speed is 2 is to 3. Fine. So this is how we can do these kinds of questions. Okay. So we are able to find the ratio of their speeds. Fine. Um, and let's move on to the next question. Okay. Look at this question. What this question is saying: two cars move simultaneously from point A and B towards each other. The speed of the two cars are S1 is 20 meter per second and S2 is 25 meter per second. Okay, find the meeting point if DAB is 900 kilometer. Okay, find the meeting point if DAB is 900 kilometer. So basically meeting point we have to find out the time. Okay, we have to find out the time. Now this A and B is given 900 kilometer, but uh, obviously we know 1 kilometer is equals to how many meters? 1 kilometer is equals to 9,000 meters. Okay, 1 kilometer is equals 1 kilometer is equals to 1,000 meter. So you have 900 kilometers, so that will be equal to 900 into 1,000. Okay, so 9 into 10 to the power 5 meter, because this is given in meter per second, so your distance should also be in meter per second. Okay, 9 into 10 to the power 5. Fine. Now the ratio of their distance S1 divided by S2 is equals to D1 divided by D2, because the point at which they will meet will be the same. Okay, so this will be what, 20 divided by 25, and what is this? This is 5 4 times, this is 5 5 times. Okay, so the ratio of their distance is how much? 4 by 5. Okay, now you know d1 plus d2 will be equal to 900 kilometer. Okay, so you know this 4x plus okay, this 4x plus 5x is equals to 900 kilometer. So that means your x is 100 kilometer. Okay, your x is 100 kilometer. Fine. Okay, so your x is 100 kilometer. That means that this d1 is going to travel how many meters? D1 is going to travel 4 into 100 into 10 to the power 3. Okay, 4 into 100 into 10 to the power 3. Okay, so time will come here in seconds. Okay, time will come here in seconds. Okay, so obviously you know speed into time is equals to distance, so time is equals to distance upon speed. Okay, now you have this d1 is travel this d1 or car c1 is traveling 20 meter per second. Okay, so you are having 4 into 100 into 10 to the power 3 divided by what is the speed? 20 meter per second. Okay, 20 meter per second. So your this and this can cancel, your this and this get cancel. So you have 2 into 10 into 10 to the power 3. Okay, 2 into 10 into 10 to the power 3. That is, they will meet 2 into after 2 into 10 to the power 4 seconds. Okay, now you can obviously convert this thing into what? Into minutes or hours, whatever you want. But this was given in seconds, so we calculated this in second. If you want to calculate, you can obviously calculate this in hours. Okay, you can obviously calculate this in hours. We'll see how we'll do it. Okay, now see. Okay, guys, look at this question. A train meets with an accident and moves at 3 by 4 of its original speed. Due to this, it is 20 minutes late. Find the original time for the journey beyond the point of accident. Okay, so in this question, what is actually happening? Obviously, see, it is saying that the speed becomes 3 by 4. Okay, the speed becomes 3 by 4, and then the time becomes 4 by 3. Okay, because actually it is saying what, that s1 by s2 is equals to 3 by 4. So you already know that the ratio of time is equals to what, t2 by t1, that will be 4 by 3. Okay, because the ratio is inverse, the ratio of time is inverse. So earlier when we were taking, like for example, we were taking 1 hour. Okay, so now you will take 4 by 3 hours. Okay, now so now you will take 4 by 3 hours. Fine. So from here actually what information we are getting, that when our speed becomes 3 by 4 times, then our time becomes 4 by 3 times. Okay. So extra time is how much? How much is the extra time? 1 by 3. Okay. 1 by 3 of the original time is extra time. Now this 1 by 3 is equals to how much? 20 minutes. Okay. So that means entire time is equals to 60 minutes. So earlier the total time taken was 60 minutes. Okay. Earlier the total time taken was 60 minutes. Fine. Now, okay, only this much is asked in the question. Okay, fine. Okay, fine. Only this much is asked in the question. Okay, so see, understand this question very well once again, because this question is done intuitively. So let us understand this question. See, earlier this was moving at S1 speed, okay, from A to B. Now here, let us say after this X, this train meets an accident. Okay, so from here to here, let us say that Y distance is left. So when they were traveling this distance in S1, the journey was completed in time T1. Now this thing is constant whether we consider it or not, it will make no difference. This when the speed becomes S2, that is 3 by 4 by S1. So S2 by S1 is equals to 3 by 4. So that means T1 by T2 is equals to 4 by 3. Okay. So that means what? The new time T2. Okay, the new time T2, that will be 4 by 3. Okay, that means 1 by 3 extra time is taken, because 4 by 3 is what? 1 part plus 1 by 3 part, and this extra time, 1 by 3 extra time, is equals to how much? 20 minutes. So the time is what? The time is the total time earlier was 60 minutes only. Okay, because this only we have to find. So this is a very easy but very intuitive question. Okay, so try to understand this very well. Okay, so I hope you must have understood this thing. Now let us move forward and look at the next question. Okay, now it is asking a body travels half the journey at a speed 20 km per hour and other half at 30 km per hour. Find the average speed. Okay, find the average speed. Now see, it is saying a body travels half the journey at 20 km per hour. So see, here distance is same, here distance is same. Here what is what is not constant? Okay, so actually, what is the average speed? Average speed is equals to total distance traveled upon time taken. Okay, total distance traveled upon time taken. Fine. Okay. Now see what we are doing here. Uh, uh, when our distance is constant, because this distance is d only, so when distance is constant, so you know s into t is equals to d, so s1 by s2 is equals to t2 by t1. Okay, so what is the ratio of a speed? Okay, the ratio of a speed is 2 is to 3. So the ratio of time traveled will be how much? 3 is to 2. Okay, 3 is to 2. Fine. So now see, obviously average can be found by what method? Distance traveled into time taken. Okay, so let us consider this 3 T2 by T1 is equals to 3 by 2 is equals to x. Okay, is equals to 3 by 2 is equals to x. Okay, so we have here what? We have this T2. Uh, okay, uh, T2 is equals to T2 by 3 and T1 by obviously 2 is equals to x. So you have T2 is equals to 3x, T1 is equals to 2x. See, we can do this by simpler method also, but I am telling you long so that you don't make any mistake. Okay, so now you have time and now you have the distance traveled. Distance traveled will be how much? Distance traveled will be 2d. Okay, and time how you can give time, obviously one thing is you can give by d by s1, okay, or plus d by s2, okay, but you can give by this method also. Okay, so see here time is how much time is, if we take by this method d by s1 plus d by s2. Okay, so this will actually become what? This d and d will get cancelled. Okay, and then you have s2 plus s1 divided by s1 s2. So this will become 2 s1 s2 divided by s1 plus s2. Okay, so now this becomes what? 2 into 20 into 30 divided by 20 plus 30. Okay, so this will become how much? 2 into 20 into 30 plus this will be 50. Okay, so this will become how much? This and this will get cancelled and your becomes it becomes this will become 4 times. Okay, so this will become how much? 2 into 4 is 8 and 8 into 3 is 24. So you will get your average speed is 24. Okay, you will get your average speed is 24. So fine. So he by this method 9 minutes. Okay. See, look at this table conversion. Okay, so we have 1 kilometer per hour is equals to 1000 meter per hour. Okay, or it is equals to 1000 uh, divided by 3600, that is equals to 5 by 18 meter per second. So whenever you have to convert any speed in kilometer per hour to meter per second, you will just multiply that by 5 by 18. Okay, and whenever you have to convert some speed in meter per second to kilometer per hour, you will just multiply this that by 18 by 5. Remember this. Okay, so whenever you have any speed and you have to convert from kilometer per hour to meter per second, just multiply this that by 5 by 18. And whenever you have any speed that you have to convert from meter per second to kilometer per hour, just multiply that by 18 by 5 and then you will get your answer. Okay, so let us move forward. Okay, let us do some of the questions. Okay, now look at this question. It is saying a man travels from his house to his office 5 kilometer per hour. Okay, 5 kilometer per hour, and he reaches 20 minutes late. Okay, and if his speed had been 7.5 kilometer per hour, okay, if his speed has been 7.5 kilometer per hour, he would have reached office 12 minutes early. Find the distance from his house to his office. Okay, so here distance is equals to constant, so we get our ratio s1 by s2 is equals to t from his house to his office at 5 kilometer per hour and reaches office 20 minutes late. If his speed has been 7.5 kilometer per hour, he would have reached his office 12 minutes early. Okay, he would have reached his office 12 minutes early. Find the distance from his house to his office. Okay, so you have speed is equals to s1 by s2 is 5 by 7.5 kilometer. Okay, 5 kilometer per hour and 7.5 kilometer per hour. This is the speed s1 by s2, and this is equal, this is inversely proportional, so that is equals to t2 by t1. Okay, so that is equals to t2 by t1, so that is 5 divided by 7.5 is equals to t2 by t1. Okay, but now you see this t2, this t2 is what, see the time taken t2. Okay, so t2 is the speed taken, speed that is available, sorry, t2 is the time taken when you are traveling with 75 kilometer per hour. Okay, sorry, 7.5 kilometer per hour. T2 is the time taken when you are traveling with 7.5 kilometer per hour. Okay, so let us take this as t2. Now this is 12 minutes less than the correct time. Okay, and this is 20 minutes late than the t1 time is 20 minutes late than the correct time. So let us consider some correct time is equals to t. Okay, correct time to reach the office is equals to t. Okay, okay, but consider this thing, t2 will be lesser time because the speed is more. Okay, so and what is the difference between time t1 and t2? So t1 is equals to t2 plus 32. Okay, so T1 is equals to T2 plus 32. Are you getting this? How? Because see, this T1 is reaching 20 minutes late and this one is reaching 12 minutes early. So we can write T1 is equals to T2 plus 32. Okay. Now see, T2 by T1 is this ratio and we know this is T2 only and this is T2 plus 32. Okay. Now we can do our calculation here. What is the calculation? This is 5 1 times, this is 1.5 times. So we have this T2 plus 32 is equals to 1.5 into T2. Okay. Now this is becoming 0.5 times into T2 is equals to 32. So T2 is going to be how many minutes? T2 is going to be, see, this is 1 by 2 is equals to 32 and T2 is going to be 64 minutes. Okay. T2 is going to be 64 minutes. Now it is asking find the distance from his house to his office. Okay. So T2 is equals to 64 minutes you have. Fine. We have this as 64 minutes. Now distance is equals to what? Speed into time. Okay, distance is equals to speed into time. But see, this distance is in kilometer per hour, so you have to convert this into you have to convert this into what? You have to convert this into your hours. Okay, so 64 minute is equals to 64 divided by 60. Okay, this much hours. Okay, fine. So this is basically just, or and if you want to find out the time, find the distance. So distance is equals to speed into time. Now this time t2, okay, this time t2 is taken in this 7.5 kilometer per hour. So just write this 7.5 kilometer into 64 by 60. Okay, into 64 by 60. Multiply this and you will get your answer. Okay. So this is going to be how much? Okay. So this is going to be let us do this. Um we have this as um 60, I think 12 5 times is 60. Okay, so this is divisible by 4. Okay, so 4 16 times, I guess. Okay, 4 1 times. Okay, and this is 4 fours are 16, and this will be 4 1 times, obviously. Okay, and 4 fives are 20. Okay, now obviously this 15 you cancel this one time, and this 15 you will cancel this how many times? 0.5 times. Okay, and when you multiply 16 into 0.5 you will get how much? 8, because 16 into 0.5 is exactly 16 divided by 2, so you get as 8. So the distance you get is 8 kilometer. Okay, so the distance you get is 8 kilometer. I hope everybody is clear with this thing. See what we are doing in this question. See, we already know that S2 by S1 or S1 by S2 is equals to T2 by T1. Okay, now we know this T2, either you can do this t2 is equals to t1 minus 30, or you can do t1 is equals to t2 plus 30. Both the things are same. You can put any one of this here. You know the ratio, you calculate the time, and when you multiply speed into time you will get your distance. So this is the simple explanation of this thing. Okay, this is the simple explanation of this thing. uh, uh, okay, and I have told you already that whenever you have to convert from kilometer per hour to meter per second, so do this 1000 divided by what 1000 divided by 3600, and whenever you have that is multiply this by 5 by 18. Okay, so kilometer per hour to meter per second, whenever we have to convert, we'll just multiply this by 5 by 18. Okay, and meter per second, we have, when we have to convert this into kilometer per hour, we'll just multiply it by 18 by 5, and that is it. Okay, and that is it. So fine. Okay, so let us move forward. Now relative movement can be viewed. Now we are going to see the relative movement. Okay, when two bodies are moving and they are moving simultaneously, so we'll see what kind of conditions are made here. Okay, so let us begin. So let us begin with this. Okay, so let's now go deeper into solving some questions. 3 by 2 is equal to be T3 to find. Okay, so so let us begin with this concept. Now you see you have this relative movement can be viewed as the movement of one body relative to another moving body. Now let us start with this. Now see, when we are talking about relative movement, okay, so basically there are two cases, okay. The case one is when two bodies are moving towards each other, okay. The case one is when two bodies is moving towards each other. So consider that you are standing here and I am standing here, and both of us are moving towards each other. Okay, consider this, that you are standing here and I am standing here. Now you are traveling with speed s1, I am traveling with speed s2. So now basically we are approaching each other with the speed s1 plus s2. Okay, because you are also covering distance with some speed and I am also covering distance with some speed. So our relative speed will be s1 and plus s2. Why? Because both of us are approaching each other with speed s1 plus s2. Okay, both of us are approaching each other with speed s1 plus s2. Okay, we are coming towards each other, or we are moving towards each other, which is speed s1 plus s2. So this is one condition. What is another condition? That you are moving towards this direction and I am moving towards this direction. So both of us are going far from each other. Okay, both of us are going far from each other, but okay, uh sorry, so when we are going towards this, so if we are moving far from each other, okay, so we are traveling in opposite direction, so both of us are moving far from each other with the speed s1 plus s2. Okay, because you are moving far from me with the relative speed s1 and I am moving far from you with the relative speed s2, so the distance is getting increased, so we are moving far from each other with the speed s1 plus s2. Okay, so this is when we are moving in opposite direction. Okay, when we are moving in opposite direction towards each other, then also s1 plus s2, and when we are moving in opposite direction away from each other. Okay, so then also we are having s1 plus s2. So these are the two cases of what? These are the two cases when two bodies are moving in opposite direction at a speed s1 plus s2 respectively. Okay, when two bodies are moving against each other for s1 plus s2 respectively. Now we have two bodies are moving in the same direction. Okay, two bodies are moving in the same direction. So we have you are starting from here and I am also starting from here. Okay, now you are traveling with the speed s1 and I am traveling with the speed s2. Let us consider that your speed s1 is greater than my speed s2. Okay, so our relative speed will be what? S1 minus S2. Okay, our relative speed will be S1 minus S2. And then one more condition will be there, that see, we are moving in the same direction. Okay, we are moving in the same direction. So see, when we are moving in the same direction, we have only this condition. Okay, so in this case, if my speed is greater than your speed, s2 is greater than s1, so then our relative speed will be s2 minus s1. So we are coming towards each other with the speed s2 minus s1. Okay, so this is when two bodies are moving in the same direction. Okay, fine. There is one more case when two bodies are moving toward in the same direction. So see what is happening here, that you are, let us say, moving here with speed s2 and I am moving here with the speed you are moving here with the speed s1 and I am moving here with the speed s2. So now if my speed is very much greater than your speed, okay, so then you will approach me but I will go far. But if your speed s1 is greater than s2, then somewhere down the line you will chase me. Okay, if your speed is greater and my speed is less, so somewhere down the line you will chase me. But if my speed is greater, your speed is less, then our distance will go on increasing. Okay, so that is it. So this is all about the relative speed. Now let us see something. So this is when we have seen the simple concept of relative speed. Now we have this two or more bodies starting from the same point and movement in the same direction. The relative speed is s1 minus s2. Okay, now let us consider the cases. In the case of bodies moving to and fro between 2 points A and B. Okay, so these are 2 points A and B. Fine. So now you started moving and I started moving. You started moving with the speed s1. I started moving with the speed s2. Okay, let us consider that your speed s1 is greater than my speed s2. So you reached first here B point s1 and then you returned with s1 speed only. But I am still going. Okay, I am still going. Okay, but so when I am going and you are also going in the same direction, our relative speed is what? S1 minus S2, because your speed S1 is greater than my speed. Now, but then you will turn from here, or when this A person, the person who first got to the point B will turn. So now S1 is in this direction and S2 is in this direction. then the relative speed will become s1 plus s2. Okay, then the relative speed will become s1 plus s2. Okay, now see what will happen, that this person will again reach here and will turn this way s1. Okay, but this person, okay, this person, when this will come and turn here, so then again what, then you are moving in opposite direction, your speed will be s1 plus s2. But when this person has turned in this direction, okay, for example, if this person, this s2 has turned but s1 has still not turned, s1 is in this way here, then again your speed will become s1 minus s2. Okay, so this condition will keep on moving. So whenever someone is turning or someone is in opposite direction, so now the relative speed will be alternate between s1 minus s2 and s1 plus s2, and then s1 minus s2 and s1 plus s2 every time any one of the body reverses direction. Okay, so whenever s1 will reverse direction, then the relative speed will move. Whenever s2 is changing direction, then the relative speed will change. And whenever now whenever you change the direction, any one of us changes the direction, s1 or s2, then the relative speed will change. Okay, then the relative speed will change. So this is, now see, for every meeting the total distance covered by the two bodies will be 2d, where d is the distance between the extreme points. So what I am saying here is that you start moving s1. Okay, now your speed is higher, your speed is higher, you went, okay, and then you turned. Okay, now this person also is traveling s2. Okay, and this turn, but this was somewhere here. So let us consider that this distance was x and this whole distance was y. So x plus y is equals to what? X plus y is equals to 2d. Okay, x plus y is equals to 2d. Why? Because this s1 has come and return at this point. Okay, and this s2 is x here at this point. So this plus this is d, and already this s1 has traveled d. So the total distance traveled by the two bodies will be 2d between any 2 points. So whenever they are meeting, they would have covered distance 2d. Okay, between any 2 point. Okay, now see, this 2D distance would be applicable only if both the bodies reverses the direction between two meetings. Okay, so for example, if let us say that we have this s1. Okay, and now somewhere we are meeting here. Okay, somewhere meeting here without changing the direction. So if we are not changing the direction, this 2d distance will not be applicable. That will have to calculate by case basis. Okay, if somebody is not turning, then this 2d distance will not be applicable. That distance when someone is not turning direction, that will be have to calculate on case by case basis. Okay, that we will have to calculate on case by case basis. So this is how we do all these kind of questions. Now let us see. Okay, now in case of the bodies continuing to move in the same direction without coming to an endpoint and reversing the direction. Okay, so what this case is, what in case of the bodies continuing to move in the same direction without coming to an endpoint and reversing. So see, this body is traveling with the speed s1 and this body is, let us say, traveling with the speed s2. Okay, so what will happen, that both are starting simultaneously. The faster body, let us say s1 is the faster body, it will take lead and will keep increasing the lead, and the movement of two bodies will be governed by the relative speed s1 minus s2. Okay, so this speed will be s1 minus s2. Fine. Now look at this case. If both the bodies are moving in opposite direction, their relative speed is given by s1 plus s2. Okay, so both are moving in opposite direction. Let us first consider this case. Okay, so their relative speed is s1 plus s2. Now, in case of the bodies moving to and fro between two paths A and B, starting from opposite ends. So this is the case that you have to go from A to B and B to A, and this will continue. Okay, now see, whenever they will meet, so the distance traveled will be d. Okay, whenever they will first meet, their distance traveled will be t. Okay, so s1 came here Okay, S2 came here. Okay, and both are meeting at this point. So total distance traveled by both of them together is D. Now see what is happening. Let us consider this S1 person is having the greater speed. So ye gaya. So it went here. Okay, it went here, and they traveled S1. Okay, and they traveled S1, and then you have this S2. Okay, and then you have this S2. This went, but see what happened here. This one changed its direction, but this one is in similar direction. Okay, now see what will happen. First, for the first meeting, the total distance covered by the two bodies will be D. Okay, fine. And thereafter, as the bodies separate and start coming together, the combined distance to be covered is 2D. Why? Because see, now this S1 has turned, but S2 is still moving towards this direction. Okay. See, now this is becoming similar to what? Now this is becoming similar to our first case. So remember this thing very clearly, that whenever you are moving towards each other and in to and fro direction, so the first point of meeting both the bodies together will cover distance D, and then what will happen, then they are moving in opposite direction, then they are turning. Okay, and then after some time this will also turn, so by that time they would have covered distance 2D. So now between every meeting they are going to cover distance 2D. Okay, so the first meeting will be covered in distance D, and then the next meetings will be covered in distance 2D. So remember this thing. This is the case in that. Okay. Now look at this question. It is saying two bodies A and B start from opposite end of P and Q. Okay. Of a straight road. They meet at a point 0.6 D. Okay, they meet at a point 0.6d from P. Okay, 0.6d from P. Find the point of their fourth meeting. Okay, find the point of their fourth meeting. So it is asking that when the fourth time actually they are going to meet, where they are going to meet. Okay, where they are going to meet. So let us try to calculate this. Okay, now see. Here what we are having, see how we can do this question. The total distance, okay, it is saying 0.6 d from P, and this P and Q are on the opposite are on the opposite us pe road pe. Okay, are the opposite points in the road, and from P they meet at 0.6 d. Okay, so that means this is 0.4 d. Okay, this is 0.4 d. Now see here, what is constant? Time is constant. When time is constant, so the ratio of their speed is s1 by s2 is equals to d1 by d2. Okay, so obviously whoever is starting from P we are taking S1, and whoever is starting from Q we are taking S2. Okay, so we have this S1 by S2, that is ratio of their speed is 0.6 divided by 0.4. Okay, 0.6 divided by 0.4, so that is 3 by 2. Now you got the ratio of their speeds. Okay, now you got the ratio of their speeds. Now the question is asking find the fourth point of their meeting. Okay, find the fourth point of their meeting. Okay, now see, we already know that we in the earlier, when we were reading the concept, we established that when both the bodies start moving toward each other, the first point they will meet at will be D. So the first point when they will meet, they would have covered the distance D, but from the next meeting, every time they are meeting they are covering the distance 2d. Okay, so at first meeting they have already covered the distance d, at second meeting they are covering distance 2d, at third meeting again they are covering distance 2d, and at fourth meeting again they are covering distance 2d. Okay, so they have totally covered distance 2d whenever they are meeting. Okay, now let us divide this distance in the ratio 3 is to 2. Okay, let us divide this ratio in the ratio through 3 is to 2. Okay, so I am saying what I am saying, because see, the ratio of the distance d1 by d2 covered by both of these is how much? Is according to the ratio of the speed. So you have this distance 3 by 2. Okay, total distance covered is 7d. Okay, so I am saying this 7d, so three parts of this 7d is covered by d1 and two parts is covered by d2. Okay, so obviously 3x plus 2x is equals to 7d. Okay, so 5x is equals to 7d, so x is equals to what? 7d by 5. Okay, x is equals to 7d by 5. Now it is asking find the fourth point of their meeting. Okay, find the fourth point of their meeting. So what will be the fourth point of their meeting? Okay, now see, if it is asked find the fourth point of their meeting, find the fourth point of their meeting. So let us consider that this d1, or the person who started from here having s1 speed covering d1 distance, so he will cover how much distance? 3 into 7d by 5. So that is 21 by 5d, and 21 by 5 is equals to how much? 4.2d. Okay, 4.2d. So basically what it is saying, this person who is starting from here has covered distance 4.2d till fourth meeting. Okay, so once he would have gone, okay, so 1d, then he would have come back, then 2d, then he would have come back, then 3d. Okay, here, and then he would have come back, then 4d, and then 0.2d from here. Okay, 0.2d from here. Okay, so the point of their meeting is 0.2d from the point P. So I hope everybody understands this. Okay, and if we can see, if we calculate from this perspective also, so that will be 2 into 7 into d. Okay, divided by 5. So this is 14.5, and 14.5 is how much? 2.8d, 2.8d. So if we are calculating from here, so 2.8 is what? One distance here, one distance here, and then zero point 0.8 from here. So zero point 0.8 from here is actually 0.2 from here only. Okay, so we get the same answer. Okay, we get the same answer. So I hope everybody is clear with this question, how we did this. See, listen carefully what all we did here. We studied, when we were studying the cases, we came to know, okay, we came to know that whenever they will travel towards each other, so first point, at their first meeting point, both of them have covered the distance d. Okay, both of them, they have covered the distance d. Now what is happening? One is going to move this side and another is going to move this side. Okay, another is going to move this side. Okay, now when again they will come and meet. Okay, when again they will come and meet, so they would have covered distance 2d. Okay, when again they will come and meet, so they will have covered distance 2d. So whenever two bodies are trying to move towards each other from point A and B, the first meeting will be at D, the second meeting will be at 2D, and the third meeting will be at 2D, and so on. Okay, so now in this question, the question asks us, tell us the point where they will have their fourth meeting. Okay, tell us the point where they will have their fourth meeting. So first meeting we had at T, second meeting we had at 2D, third meeting again they would have covered distance 2D, and fourth meeting again they would have covered distance 2D. So till the time they are meeting for the fourth time, they have covered the distance 7D. Okay, now because time is the same, the time for which they were traveling, both of them is the same, so we will apply our equation s1 by s2 is equals to d1 by d2. So s1 by s2 is equals to d1 by d2, that is the ratio of their distances covered, will be in the ratio of their speed. Okay, will be in the ratio of their speed. Okay, so again the ratio of the distance covered when they met first, so that was 0.6d divided by 0.4d. Okay, so that became how much? 3 by 2, 3 by 2. Okay, so s1 by s2 is equals to 3 by 2. Fine. So when they are covering this distance 70 also, then also their ratio of distance will be d1 by d2 will be 3 by 2. Okay, so okay, so then also their ratio of distance will be 3 by 2. Fine. So this will become what? 3x plus 2x is equals to 7d. So that means we get 5x is equals to 7d. and d1 is equals to how much? D1 is equals to 3 into 7d by 5. So that comes to be 21d by 5. So that is equals to 4.2d. Okay. When this is equals to 4.2d, so that means what? That means that we have 4.2d, and this person who is doing from P, first he is covering this distance, then he is coming back and covering this distance, then he is going back and covering this distance. So this is D, 2D, 3D, and now coming back and covering this distance 4D and 0.2D from here. So the meeting point will be 0.2D. Fourth meeting point will be 0.2D. Okay. So this is how we got this answer. So I hope everybody is clear with this thing. Let us move on to the next concept. Okay. Or sorry, next question. Okay, fine. Now let us look at this question. A starts walking from a place at a uniform speed of 2 km per hour in a particular direction. After half an hour, B starts from the same place and walks in the same direction as A at a uniform speed and overtakes A after 1 hour 48 minutes. Calculate the speed of B. Okay, see what is happening. A starts walking from a place at a uniform speed of 2 kilometer per hour in a particular direction. Now, after half an hour, B comes and B starts walking from the same place and walks in the same direction and overtakes A after 1 hour 48 minutes. Okay, after 1 hour 48 minutes. Okay, see, this B person is saying that it overtakes A after 1 hour 48 minutes. Okay. So B is traveling for 1 hour 48 minutes and A is traveling for 1 hour 78 minutes. Okay. A is traveling for 1 hour 78 minutes. Now 78 minute is what? 78 minute is 60 plus 18. Okay. So that is A is walking for 2 hours 18 minutes. Okay, and B is walking for 1 hour 48 minutes. Okay, so we have this time T1 and T2. Fine, we have this time T1 and T2. Now, when they are overtaking each other, so what is constant here? Distance is constant here. Okay, what is constant here? Distance is constant here. Fine. So now when distance is constant here, that means you have the ratio S1 by S2 is equals to T2 by T1. Okay, so that means SA by SP is equals to TB by TA. Okay, now what is the time taken by this TB? Okay, the time taken by this TB is 1 hour 48 minute. Okay, 1 hour 48 minute, that is 1 plus 48 divided by 60. Okay, 1 plus 48 divided by 60, and this will be 2 hour 18 minutes. So that is equal to what? That is 2 into 18 divided by 60. Okay, 2 into 18 divided by 60. So actually this is the time they are taking. Okay, so here from here you can calculate the ratio of their speed because SA is already given. Obviously you will be able to calculate SB. Okay, uh, obviously you will be able to calculate SB. Okay, so let us first calculate this. What is TB by TA? Okay, what is TB by TA? Okay, so you have this TB by TA as how much? Let us calculate this ratio. Okay, so you have this as 60 plus 48 divided by 60, so that is 108 divided by 60. Okay, and TA is how much? 120 plus 18. Okay, 120 plus 18 is 138, so 138 by 60. Okay, so now you have this TB is how much? 1 hour 48 minutes, so that is equal to how much? um that is equal to 108 divided by 138. Okay, 108 divided by 138, 60 and 60 will automatically get cancelled. Okay, so now calculate this ratio. So let us start dividing this by 4 only. So 4, I think this will be divisible. Okay, oh, let us divide this by 2 only. So we have this 54 and we have this as 2 6 are 12 and 2 9s are 18. Okay, let us divide this by 3. Okay, so this will go how many times? 3 ones are 3. Okay, and you have this 3 8s are 24, and this will go how many times? This will go 23 times. Okay, so you have this in the ratio 18 by 23. Okay, you have this in the ratio 18 by 23. Fine. So SA by SB is equals to 18 by 23. So this SA will come, SA is how much? This is 2 and this is 23, and you divide this by 18. So you get your SB, so that is 23 by 9. Okay, you will get your speed as 23 by 9. So this is in kilometer per hour obviously, and then you will get your speed. Okay, so this is how you do this kind of question. So you have this, obviously you are getting SB as 23 by 9 kilometer per hour. Okay, that is the speed of the V is 23 by 9 kilometer per hour. So this is relatively easy only. We just have to consider that distance is constant when you are overtaking. Okay, so very easy question. Okay, let us move on to the next one. See, now we are taking one more case. In the case of the bodies continuing to move in the same direction without coming to an end point, okay, and reversing. See, when both the bodies are moving in the same direction and they are not coming to an end point and they are not reversing, then obviously just the distance, the difference of distance between the two can be calculated by how? The relative speed into time. Okay, the relative speed into time, that will give you the distance between them. So that is it and nothing else. Okay, so I hope everybody is clear with this thing. So we'll meet in the next class.